gas machine gun simulator. The gas machine gun simulator uses oxygen and propane to produce a weapon-like impact. Then let me show you this video. Yes. Like this video, it doesn't fire properly when you keep shooting. So we looked at this video and we made the assumption that incomplete combustion can cause a misfire. And in order to detect it, it is necessary to measure the remaining propane and combustion byproduct CO after incomplete combustion. So we made a plan to prove the hypothesis. First is collecting propane and CO data using a sensor. Second is to visualize the data with graphs. And third is doing a cost analysis based on graphs. Now we'll talk about our approach. Our approach is 3 areas. First is circuit. We use the MQ2 sensor from the Grove company. This sensor can measure the propane and CO generated during the incomplete combustion. And the data from this sensor is collected using Arduino. Second is hardware. We made a total of 5 prototypes. 4 modifications were made to make the final prototype, mainly because high pressure in the battery and high temperature around the battery. Therefore, this last prototype is added to the hardware to protect the sensor. It protects the wires of the sensor and also withstands both high temperature and high pressure as the distance between the battery and the sensor increases.
The last one, for visualization, we made a dashboard. So we use language R because it is good at presenting graphs and applying statistics. And we use library Shiny for making dashboard as website and Plotly for presenting graphs interactively. So after our preparing, we test all sensors doing well. We showed pure propane at each sensor, and we get those data. The blue line is the sensor 0, and green line is sensor 1, and orange line is sensor 2. When we shot propane at sensor 0, as you can see, sensor 0 and sensor 1's value is increasing, and when we shot at sensor 1, sensor 1's value is increasing, and when we shoot at sensor 2, the sensor 2's value is increasing. There is some difference, but we can check all our sensors doing well. So after test all sensors doing well, we went out for collecting data. We test this machine in sets of 5. We doing 2 tests. First one is without oxygen to induce abnormal firing, and second one was with oxygen to induce normal firing. We use 3 different types of barrel: 556 and 762 and 50 cal. The 50 cal one is the most effective. I guess that it fires more gas than others. So let me show you a video. This is the burst field testing, a test without oxygen. As you can see, this is the abnormal firing because there is no oxygen.
So it must be misfiring, right?
Yeah, misfiring. And this is the second field testing. It is the test with oxygen. This is the normal firing. So we got those data on the first test. Left one is propane and right one is CO. They look similar with both, but there is a difference because of the barrel size. So we found something on those data. So let me tell what it is. Those two are CO and propane graphs of tests without oxygen to induce abnormal fires. As you can see, there is a similar tendency between both. And those are the graphs of CO and propane of the test with oxygen. They look similar each other, but there is much more smaller variance than the test before. There is abrupt increase in this section because there is abnormal firing on those sections. So two above are the CO and propane, the test without oxygen, and two below are the CO and propane test with oxygen. So we applied the Holt method for getting expected variance. So as you can see, there is a similar tendency of expected variance depending on the experimental environment, and there is a big difference between tests with oxygen, without oxygen, and with oxygen. So our conclusion like this, and we can judge that our assumption is almost right. Propane and CO are the clue of the detection of normal firing. So there is some point for the future work. First, our sensor was a little bit slow, so a faster sensor is needed for a more accurate experiment. And if we can see this clear difference like this, we can also make the computer detect a difference automatically. So, thank you for listening.